jump in and actually get started on exam number 2. So, in the first question, we have an object, and we're given its position as a function of time, and we want to figure out what it's doing. So let's just kind of review really quickly on the choices. If something's standing still, its position versus time graph would look like this. If it's moving at constant velocity, its position versus time graph would look like this. Or with a negative slope. Now, if it's speeding up, actually that's what this graph is doing, and the correct answer is in fact choice C. But what I want to talk about really quickly is just sort of what's going on here. When you start off with a very flat slope, and please remember that flat slope, well, that means slow, and then a steep slope means faster. Okay, and this actually gives us a clue about how we're going to do our next problem. So it says the velocity versus time graph of this object. Well, this is actually what constant velocity looks like, and that's constant positive velocity. That's constant velocity moving forward. This is actually constant negative velocity. This actually tells you your velocity is increasing, but at a non-constant rate. And actually, in this graph here, the one answer that applies is C, where your velocity is actually increasing in a positive direction. Here, we're increasing in a negative direction, so that would be going faster going backwards. This is going faster going forwards. So I'll actually just write here, faster going backwards. So that kind of gets us done with that one. Now, what is the object in this velocity versus time graph doing? Well, one of the things that people do after months of not studying this stuff is that they think that this thing means it's moving backwards. And that's completely wrong. It's not moving backwards at all. So moving backwards, that is the wrong choice. Wrong. Forget it. What's actually happening is that we start off with a positive velocity going forward, and our positive velocity going forward gets less and less and less until it stops. So what's happening is that we are slowing down to 0 from some initial positive velocity. By the way, if you were wondering what the graph for choice B looks like, that would be this. For choice C, that would be this, where this is a V versus T graph, and this is also a V versus T graph. And then for D, moving at a constant velocity in the positive direction, that would be this. So this would be your time, and this would be V as a function of time. And then for E, sitting still, not moving, your velocity versus time graph would be a flat line on the x-axis like that. So that's good stuff to know. Now, what is the object in this velocity versus time graph doing? Well, here's what actually happens. First of all, whenever your velocity graph touches 0, 0 means stopped. That's bad handwriting. So again, let me just try to write that. 0, right there, this little point there, 0 means stopped at that time. So here we start off negative velocity, and then we start going to positive velocity. So we really need to be clear that it stops at some point, and then speeds up. So we're at a negative velocity, and then we're at a less negative, and then we stop. So what's happening is we're going in a negative direction, slowing down. We stop, and then we speed up in the positive direction. So we need to find the choice that actually says that. So positive in the negative direction, no, that makes no sense. Initially moving in the negative direction, that might be a good one. It slows down, stops, and then speeds up in the positive direction. So choice B is actually the choice that we are looking for. Now, which of the following is a velocity versus time graph for an object that is moving in the negative direction at constant velocity? We already talked about that on the previous page, and that's D. Now, what you should do to practice is you should identify what each of these graphs means. That would actually be a really good thing for you to do, and be able to explain it to somebody else and actually check it with somebody else. So the easy, lazy way is to just do it and check with me. And I'll just tell you right now, I'm going to make you check with at least one other person before, and have evidence that you've checked with one other person before I answer that question. No. We are, okay, so we throw an object. So for question 6 to 8, we have this object. We throw it vertically upwards at the speed of 20 meters per second, and we define down as negative. We want to know the velocity of the object at the highest position in its path. At the highest position, it's stopping, getting ready to turn around. Now, the acceleration of the object at the highest position in its path is always negative 9.8 meters per second squared. We talked about that in class, that when you throw something in the air with no air resistance. So, again here, when there is no air resistance, acceleration for a thrown object is always negative g. Excellent. Now, the velocity of the object, when it comes back down and you're about to catch it, well, let's think about this. I start off at 20 meters per second positive, okay, throw it up into the air, it stops, and then it falls back down to its original point. Now, this is one of those things that we'd actually done the math to prove it in class, but it turns out that you're starting and ending speed. If you start and end from the same height, and there's no air resistance, you actually end up getting the same speed, but in the opposite direction. So that's something I actually don't feel like proving right now. It takes a small amount of time. I just don't want to do it on this video because we've done it several times before in class. Now, an object's position is increasing at an increasing rate. That means it's speeding up. So which of these scenarios would mean that? I'm speeding up in the positive direction. So roll down a hill in the positive direction would do that. So now here, an object has a positive velocity with negative acceleration. That means it's going forward and slowing down. So which one of these would do that? Let's see. Running towards me, that's not slowing down. Picking up speed, that's not slowing down. Constant velocity for C, not slowing down. Speeding up here, that's for B, that's speeding up if it falls. So the only one that works is choice A. Okay. Now the next one. An object is moving in the negative direction with a negative acceleration. People mess this one up. That means you're going backwards and you're accelerating backwards. Okay. So going backwards and you're accelerating backwards. What that means is you got to be speeding up. Okay, now, a good model rocket reaches a height of 500 meters. The model rocket as actually reaches this height was the initial velocity with which the rocket was launched. We got a choice of formulas, and you just got to memorize these. So v squared equals v naught squared plus 2 times negative 9.8 times y minus y naught. So we start off from 0, and we have 0 speed at the top equals v naught squared plus 2 times a negative 19.6 times 500. So v naught squared is going to be, I'm going to do a little something here, and you can do this on the exam to help you, but if you have any doubt at all, don't do this. I'm going to round. And this actually ends up giving me, if I have this right, 10,000? Yeah. 10,000, so when I take the square root of that, v naught's going to be 100 meters per second, and that gives me choice D. Now, number 13, we have a height record for a basketball player. He jumped 0.95 meters, and we want to know what the hang time was during the jump. So let's get half the hang time from falling back to the earth. And of course, that will actually be y equals 1/2 gt squared. And if we're at the top from falling, we have an initial speed of 0. And y naught we don't know. Y is where we land, which is on the ground, and that will be 0. So now what we can do is we can actually put in 0.95 here. So when we do that, we're going to get negative 0.95 equals, we're going to put in negative 9.8 for g, so that gives us negative 4.9 times t squared. And now we can do the math. We can solve for t. Which is 0.44 seconds. But that's only half the time. we got to double that to get the total hang time. So the hang time is going to be 0.88 seconds. That's going to be our answer. And that's how we'll do that. So good job, us. And yeah, that's it. So again, I'm just going to change this up a little bit here. We get a hang time of 0.88. So please be careful in these problems when you're doing this, that when you get a hang time, if you only solve for half the time, double it to get the total. So again, that's 0.088 seconds. Now, next one. We have an electric vehicle. It starts from rest and accelerates at a rate of 2 meters per second squared in a straight line until it reaches a speed of 20 meters per second. Then it slows down at a constant rate. We want to know how much time elapses from the start to reaching 20 meters per second. So that's actually easy. We have v equals at plus v naught. And we're going to put in here 20 equals 2 times t plus 0. And we're going to end up getting t equals 10 seconds. That's not so hard. It's not so bad. Oh, and sorry for here. Choice C is the answer for number 13. And make sure I'm circling my choices. Yes, I am. Now, for number 15, how far does the vehicle travel from start to stop? So let's actually do this in two parts. I'm going to go from 0 to this 20 meters per second. I don't know what that distance is, but I know that it reaches 20 meters per second at some point. And then, of course, it goes to 0 meters per second at the end. So I can use all that to kind of get me an answer. So with that in mind, what I'm going to do is this. I'm going to say v squared equals v naught squared plus 2a times y times x minus x naught, and just put in some numbers. So I know that I reach a speed of 20 meters per second. When I square that, that's 400. I start from 0 plus 2 times 2 times x minus 0. So when I do this, I get x for the first part of my trip is 100 meters. Now I need to get the distance that I traveled during the second part of my trip. So I'm going to actually just rework this equation again for the second part. So that's going to be 0 squared, because that's what I wind up at, is 20 squared plus 2 times negative 1 times y minus y naught. So now there's two ways you can do this. Some people put in 100, okay? So what that means is that if you were to get the x, if you put 100 in here, you're going to get the total distance you travel from beginning to the end. I'm going to split this up into two journeys, so I'm going to say, let me just reset my 0 here. So I'm going to reset this to 0 for the second part. Okay, so sorry. I'm going to reset to 0 for the second part. So when I go ahead and plug this in here, I will actually end up getting, see, 2 times negative 1 times y minus 0, so x minus 0, and what I actually end up getting here is 400 squared, and actually, sorry, I have this wrong. Do I have it wrong? No, I have 400 squared plus 2 times x, and x here, yes, it ends up being 200, sorry, it's not 400, it's x equals 200 meters for the second leg. So what that means is my total distance equals 300 meters. Okay, let me just check one thing. All right, so this is our multiple choice section. So I'm going to go ahead and stop here, and then in our next video, I'll be solving your free response.